Hey guys, how's everything going? This is JSer. In this video, let's take a look at the distributivity in TypeScript. This is not some common knowledge we use every day. It could be very useful if you are fiddling around with the TypeScript abilities. It's not. I think it's not critical for us to understand, but it's quite useful. So let's take a look. This stuff is actually documented on the official website of TypeScript, so I put a link here so you can just go there and find the official explanations. In short, when conditional types act on a generic type, they become distributive when given a union type. So there are quite some conditions here for this to work. I think there are three fundamental elements inside here. The first one is conditional type. So for now, as far as I know, only conditional types could be distributive. The second one is the conditional type itself is not distributive. It means that if it acts on a generic, then it could be distributive. And also, the distributivity acts on a union type. We'll use the basic example here to explain what it is. So suppose we have a generic type to array type here. This is actually the official example, I think, from the document. This is a generic, and also it has this conditional type. So for conditional type, it's just like, for my understanding, it's just like an if clause. While for extends this keyword itself, in TypeScript realm, it has a lot of other semantics, but here it's just a if clause. So if type is subtype of any, then we return the type, making it like array, right? So this is what we want. If it is not, then it's never. For any here, it doesn't mean anything. It's just to make this condition true. For any, we can use anything. We can use unknown here, or use this object literal, or use this bigger object, anything. The sole purpose here is to make it distributive. So this is true, so it will always return type array. So if we now for generics, it's like a function. This is the type parameter. We put a string at union. This is a third condition. A third element which is given a union type. So we have one. The conditional type here. The second, this is the generic, and this is the union here. So now it's distributive. So to array now, we get a string array, and with a union with a number array. At first sight, you might think, okay, this is type, so we put this parameter type here to type here, so we might get something like this, but no. Because conditional type is distributive, it works more like this. Like to array ABC union, it means that we apply to this function or to this generic it for each union member, and then make the result unify them, like put them together as a union type. So this is called distributivity. Super clear, right? Remember three elements here. First one, conditional type. Second one, generic. Third one is union type as a parameter. Cool. Let's take a look at more example here. I put a playground here. This is string number, string. This union type, string number. This one is if it extends any, then return string number array. Otherwise, never. Obviously, it will return a string number because, as we said, even with a conditional type is a conditional type itself is not distributive. It needs to be a generic. So its core actually is the generic to be distributive. This is not distributive. The second one to string is type extends string type. So this is distributive, right? And B3 is to string number. Yeah, generic, conditional type, and this is union type. So it is it will be a string array. The reason why it's string array is that the string number, when we distribute them, we get this one, to string array number, which actually this will not satisfy. So it will be to string array string and never. So it's string array. Yeah, cool. Now we can understand why. So here's the interesting part. You might think why we need distributivity, right? This is my guess, is that with this, we can understand why exclude could be written with extend. So here is my includes. This is my includes. Oh, here. Yeah. So here is my includes. If you take a look at the excludes in TypeScript, I think it's somehow, let's say, written the same. I think type A, look like 810 exclude. Let's say what is exclude. Yeah, you can see that exclude. The built-in exclude utility type is if T extends U, then never, then exclude it, right? Otherwise, use T. Yeah, it's just like what we write here. Exclude, if you want to exclude E from T, we say T extends E, then never, otherwise T. Well, for me it's super, like, it's not easy to understand why this means exclude, right? We might exclude string number, pass number, and then you got string. So now we know, because this is distributive. When we call exclude string number, it means that we call exclude T string number and number. And string number, it's not true here, so we got to T, so we got string. And number is number, so never. So string union with never, so we get string. So now we can know why it could be written with extend, because it's distributive. So super cool. Now we have another example is said, let's reverse exclude, like exclude T from E. We rewrite it with the reverse direction. So if E extends T, we never. So it sounds easy, right? If we say we exclude reversely, we pass a number as the first argument, a string and number union to the second union parameter. So we get a string as well. Also, we have this my exclude 2. What does this say? Okay, so it says if T extends E, then we get TE. Otherwise, we never. Well, we'll pass it along with number string, boolean number string, big N. We get this. What does it mean? It means that even though the E, so this one is a distributive, even though E is union type as well, only T here, T is distributive, you see? Number is distributed. Number, yeah, extends it. So, number. String is part here, right? So, yeah, extends it. So, this is TE. Boolean, there's no Boolean, so this is never. So, we got this. Think these that you can see that even though E is union, it is not distributed. Yeah, it depends on the position of T, right? So if you want to say, okay, what if I want to extend this E as well? Well, we already know that the one before extends, that here, T here is distributive. We can just reuse that. We add a second extend. So let's create another extend, say T extends E, and then E extends any. We just make it distributive, and then we get TE, or never. And then we pass the same type parameters in, and we get Okay, we get like number, string, boolean, stuff like, right? Yeah. But actually, you might think that, wait a minute. It's a bit strange, right? We only get 5 of them. Why? Well, let's rewrite it. If what I say? It's free. Rewrite it. T extends any. E extends any. Never. Yeah. If we don't extend E here, we extend. It's purely just distribute the T and distribute E. We get the full pairs, right? But if we get T extends E, no, we don't get it. So you see that. When we distribute the first T, the boolean actually it's filtered out. So it's identical to this one. Because for boolean, it's not in here, right? So it's only number string, so it's the same as this and this. And then E, the second argument will be distributed in this conditional type. And we get it. Right? But still, then E is distributed. But when we distribute E, we notice that the T extends E, it still needs to be satisfied. What does it mean? It means that, like say, when we distributed number, fine. Number string, nah. And there will be no number string, right? Number begin, no. String number, yeah. String number, no. String, yeah. String begin, no. So what does it mean? And the number will be here. So we get number, never string, never begin, never number, string, never begin. So we get, and there's a duplicate here, which is never begin. So we get this pair, right? Yeah. Cool. This is really interesting. Yep, that's it. Hope it helps. You understand the distributive in TypeScript. Next time you can talk like about the type system in TypeScript with more beautiful words. Distributivity. Yay.